Cool. So agenda tonight we got a relatively light agenda. The first one I just put my name on there because it felt so lonely just Patrick being up there. So I wanted to accompany him. But I'll give some brief updates on stuff that's going on in the remix world, and then Patrick Odenborg is going to share a cool demo of tRPC plus remix, which I'm super excited about. And hope others are if you are familiar with. Hopefully, you're familiar with one of those words. But yeah, anyway, it'll be cool. Is all I got to say about that. But yeah, my name is Brooks Libran. This is the Remix Awesome Meetup. If this is your first time, it's nice to meet you. I think I got to meet almost everyone at least in the room. And yeah, this is a once a month, usually kind of end of the month sort of meetup that we do. And it's about remix. If you don't know what remix is, let's just start there because sometimes there's confusion because it is a confusing name. It is a web framework right now, primarily written on top of React, but TBD on that. Hopefully I can one day stop saying that and say it's written on lots of things. But yeah, it's a web framework built by the people who created React Router and Reach UI and a couple other cool things, unpackaged and whatnot. And yeah, this meetup is just to share cool ideas and demos and learn together on how to use Remix. So that's pretty much that. A couple things going on in the Remix world. First thing is Remix European Conference, which is super exciting. So that's coming up in November. I don't think the date's actually, yep, it's tiny, November 18th. This is actually an online only conference. So good for us in the US because any of us can now go pretty easily and relatively cheaply. Bummer that it is online and there's not some, I really wanted to go to Amsterdam and that's not happening this year, it looks like. So, but hopefully next year they will be able to make it in person. I bring this up, one, so you can know about it. Two, the call for papers is currently open. So if you have a talk idea that you want to give, you should submit it. And I partly say that also because I am on the committee to look at people and their CFPs. So I don't know if that will bias me or not. We'll see. Put it to the test. I don't know. Submit something and say, Brooks, look at this. Cool. So that's the conference coming up. And then something else that's new in Remix React Router world. If you're not familiar, React Router 6.4 came out recently. Why am I talking about React Router? Well, because 6.4, if you're unfamiliar, is like them remixing React Router. So they took a lot of the cool APIs of Remix, such as like the loader functions, the action functions, and all that kind of stuff that if you mess with Remix at all, you're probably a little bit familiar with. And they kind of took it back into React Router. This is cool for a couple of reasons. One, this is the first time that React Router actually cares about your data loading, which is pretty unique. They've gone, 6 major versions without not caring about that until now. And then secondarily, if you or your company are trying to migrate from maybe a React Router world into Remix, this gives a nice onboarding path to that. So anyway, if you haven't checked it out, it's pretty cool. The tutorial is pretty thorough, which is awesome. And then on the side, I really like this. They got the little new emoji for everything that's new. So it's really easy to figure out like, oh, cool. What are the things I maybe haven't seen yet? I did a demo 2 days ago with my company, kind of walking through one of our apps and looking at what it would look like to kind of React Router 6.4-ify it. That's a terrible expression, but anyway, yeah, it was fun. I had fun. I don't know if anybody else did. But yeah. Oh, that's for later. All right. That's all I've got. So Patrick, if you're ready, we can go ahead and get going.
Yeah, I'm ready. Let's do it.
Cool. And also I am recording, right? Did it say recording in progress at one point?
Yeah, I see it in the top left.
Oh, sweet. Yeah. Awesome. Also I'm trying to figure out how to stop sharing. I swear, I use Zoom every day and I still don't know how to use it.
Where can folks find recordings if they want to reference it later?
That's a good question. So we do have a YouTube page. If you just look up React, what's this called? Remix Austin Meetup. You should see our Meetup page come up and our YouTube come up. Yeah, so it's there. It's also, it is linked in the Meetup. So yeah, we post all the talks there. If you want to do a talk in the future, we will record and then post it. Unless you tell me you don't want to be recorded, obviously we won't record you. But otherwise put it up there. And I usually try to make like a little social so that you have like kind of a snippet, 2-minute kind of version of it. So you can share on whatever you want, just to make it a little bit like nicer and kind of clean up the audio because the audio is not the best on the recordings, but be that what it is. Okay, Patrick, sorry, I took up more time. Now again, are you ready?
Yeah.
Cool.
Okay. Can everybody see me? Hear me okay?
Hey. Yep.
Okay, everybody, I'm Patrick. I've been using Remix for about a year now, and recently started a side project where I've been using Remix with tRCP. So I thought it would be a cool idea to kind of give a talk about what is tRPC, how it works, and then kind of how you could use it with Remix. And so let me go ahead and jump into my presentation. Can everybody see my presentation okay?
Yep. Yes.
Okay, and by the way, I know it's kind of difficult because I'm virtual, but if you have any questions, feel free to speak up and stop me at any time and ask me if you have some uncertainty about something I say. Okay, so let's get into it. So Remix and tRPC. I am assuming that you are familiar with Remix and you know the basics. I won't really dive into the basics of Remix, but I am not assuming any familiarity with tRPC. So I'm going to start from scratch in this talk and in the demo that I give. So let me go ahead. Okay, so let's start with why use tRPC. So tRPC is a tool that helps you build end-to-end typesafe APIs. It's completely built in TypeScript, so you get full type safety, and it's kind of a way to build APIs in such a way that the client and server share types, and they go off of a shared API schema, which is really nice because anytime any of your API routes change in the server, all of the clients that are making calls to that server will immediately know and get type hints that something has changed. It's gotten really popular lately, and I think that's partly because of the developer experience. There's no build steps, there's no code generation. Everything's going through TypeScript, so you immediately get type hints that something is off or something has changed. You get awesome auto completion for your API routes that you make with tRPC, and you also get auto completion for the arguments as well. And it's batteries included, so they have adapters for a lot of popular client and server technologies. So it makes it really easy to get up and running with tRPC. And so what is tRPC? The short answer, it's a library for building RPC APIs in TypeScript. So T stands for TypeScript, RPC stands for, well, I'm going to get into that in the next slide. So what is RPC then? If tRPC is a library for building RPC APIs with TypeScript, what is RPC? So it stands for Remote Procedure Call, and it's a convention for building APIs. And so I think most people are familiar with REST APIs because that's kind of the most popular convention or architecture. But there are others out there, RPC being one of them. SOAP was one that was popular back in the day. And so it's just a different way of building your APIs. And what's different about RPC is basically the API is a collection of public methods that the client can invoke. And so when the client is making an HTTP request, it'll send along the function that it wants to invoke on the server and the arguments that it wants to invoke the function with. And so I'll explain this a little bit more, and I'll kind of have a comparison of REST APIs versus RPC APIs so you can get a better idea of some of the differences. So for example, in REST APIs, you use HTTP verbs a lot. The semantics are pretty important. Whereas in RPC APIs, you only really use get and post, the get and post verbs. So get requests are typically used for any type of querying invocation, and posts are used for mutations. And so REST APIs tend to be resource oriented, where RPC APIs are action oriented. And then this is kind of typically endpoints in REST APIs are nouns, and the HTTP verb kind of denotes what's going to happen to that resource or that entity. Whereas in RPC APIs, the endpoints are kind of verbs, like you're literally passing the function that you're going to invoke. So kind of an example, if we had an API where we wanted to remove a user from like a Slack channel, let's say, one way we could implement this in REST is to kind of have a delete request at this path. So you would have channel, the channel ID, the user in that channel, and then the user ID. And so this could be one way that you could implement an endpoint in REST to remove a user from a Slack channel. The way that this would differ in RPC is instead of in the URL, you would actually have the name of the function. And so on our server, we would have a function called remove from channel. And so we're basically saying, hey, we're going to invoke this function with these parameters. And so we're basically using query strings to pass it the parameters that we're then going to pass into this function to invoke on the server. So that's kind of how RPC APIs are a little bit different. And so how are we going to implement this in Remix? So there are different ways you can do this. So in tRPC, there's a tRPC client and a tRPC server, right? And so one way we could implement this is we have a Remix app, and then we have a route, let's say for users. And then if we want to fetch the users, we could have another loader that's a tRPC handler. And then we could basically in one loader call the tRPC loader and kind of use Remix as both the client and the tRPC server. There are libraries. There is a community library out there that provides an adapter for Remix to allow you to do this. I don't think this is as useful as having a separate backend and then using Remix as just the client and calling another backend, which serves as the tRPC server, because this is not really the Remix way of doing things. Usually, if you're using loaders to invoke other loaders, there's a better way of doing things. And also one of the primary benefits of tRPC is end-to-end type safety. And if you're only using Remix, if like, let's say your application is just a Remix app, you're having a blog site and it's not interacting with any other system, you might already have end-to-end type safety without tRPC. So it might be overkill to add tRPC if all you're doing is interacting within your Remix app. And so this is actually kind of why I bring this up, because you may not need tRPC. And so Kent recently tweeted that he hasn't even looked into tRPC because he already has an end type safety with Remix. And so I just bring that up because tRPC is awesome. I've really enjoyed using it, but I think you should consider whether or not it's a good fit for your application. And so what we're going to be doing in this demo is we have a Remix app and we have a users route, but we're going to have a separate backend application. So we're going to have a monorepo where we're going to have a Remix app. We're going to have a backend, which could be an Express server. It could be a Lambda function, a Fastify server. And our Remix, inside of our loader, we're going to instantiate a tRPC client, and that's going to speak to our backend. And the awesome thing about this is since we have this in a monorepo and we're able to share types between the backend and Remix app, we could also later extend this and use any other TypeScript application as a client to this backend and get all the same benefits. So we could add a React Native app and written in TypeScript to our monorepo, and we would still get all the benefits of invoking our tRPC backend. So this is what we're going to kind of be building out today in this example. Minus the React Native app, we'll just stick with Remix in the backend, but this is what we're going to go ahead and get into today. So before I actually get into like coding the code demo, does anybody have any questions over what was discussed in the presentation?
We're with you so far.
Okay, awesome. So let's get into the code. So here I'm in VS Code. I have a empty folder. Now I mentioned the word monorepo. In this sense, we're just going to have a folder with multiple applications in it. I wanted to keep everything as simple as possible and not overwhelm people with new technologies that they may not have seen before. So I'm not going to use NX or Lerna or TurboRepo or any monorepo framework. I'm just literally going to create two applications inside the same folder and then share types. So what I'll do first is I'm going to create a folder for our Express application. I'm going to use Express instead of Lambda or Fastify or something else because it's pretty straightforward, and I think a lot of people are experienced with Express. So let's go ahead and set that up. So really quickly, we're just going to make it really simple. We're going to initialize our folder, and then we're going to install some dependencies. So I'm going to install Express. I'm going to install .env. I think that's all for now. That's all I really need. And then for our dev dependencies, we're going to install TypeScript, TS Node, the types for Express, and NodeMon. It's super basic. I'm going to go create a server.ts folder file. And then here's where we're actually going to set up our Express server. So basically, this is just, right now, it's all just Express, nothing crazy. Okay, and then we're going to do app equals express.
Hey, Patrick, just for some of us in the back, do you mind bumping your font up a size or two? Yeah,
Is that better?
I think that's good.
Yeah, thank you.
Thank you.
Okay, sorry about that.
Oh, good.
Okay, awesome. Oh, forgot to create a port variable, and we're going to list it on that port. Okay, awesome. And so I'm going to add a start script here. It's going to use nodemon and ts node to run this locally. So let's see if everything works out. We should be able to run this successfully. And then let's go over to our browser, just make sure that we're able to hit that route and get a hello world back. Okay, cool. So far I haven't added anything about tRPC. This is just a basic Express app, and now I'm going to install the dependencies that we need for tRPC. So tRPC is actually a collection of libraries. It's not just one library. There's a server library, a client library, and then there's a couple of libraries for specifically for React or other frameworks. So let's go ahead and install the tRPC server library here on our backend. And we're also going to install Zod, and I'll show you why in a second. Oh, I spelled tRPC wrong. Okay, awesome. And so what we're going to do, I'm going to create a new file called tRPC. And this is where I'm going to kind of put all the tRPC specific logic. So this is just kind of boilerplate stuff. You can find all this in the documentation for tRPC, and I'll show you that site towards the end of our talk, so you can reference it later. What I'm going to be doing is specific. Some of the stuff I'm going to be doing is specific to Express and their Express adapter, but they have adapters as well, like I mentioned, for AWS Lambda, if that's what your backend runs on, for Fastify, and a couple other technologies as well. So this is going to be the first tRPC specific stuff. We're going to have a create context function, and this is kind of like a middleware that runs at the beginning of all of our requests. So we can basically kind of parse the request, take things off of it, and then there is a context object that we can access in all of our route handlers. And I can kind of show you why we like some of the uses of that, but let me just go ahead and type this out here. So this should be and then right now we're just going to return an empty object because we're not actually going to use this for the moment. We want the type for this though. So we're going to do infer async return type of create context. So we have a type for that. And then we're going to create a helper function called create router. That'll basically help us create tRPC routers. I do want to mention while we're writing this out, the latest version of tRPC is version 9, and version 10 will be coming out pretty soon later this year. There are some breaking changes. So just note that everything I'm showing you here is going to be version 9. So let me see here. Okay, so we have. Let me create our router. Okay, so this is just some kind of boilerplate stuff for tRPC. We have a create context function. We have a helper function for creating routes. The reason we're doing this is because we have to pass in the context type into our route for it to work correctly. And if you have multiple routers, so if you have like a user's router, a post's router, sometimes you forget to pass in that context object, and you can end up with some subtle bugs. So I like to extract that out into its own function. So we'll do, create router. So this is like the basic setup that we need. This is like the most basic tRPC server, essentially. And so what we're going to do is we're actually going to create, like I mentioned, we can have multiple routers. So I'm going to create a user router here. So we use that create router function. And then now we can start actually defining our API routes. So remember I said in tRPC, you don't really use all the HTTP verbs. You just use get and post, get for queries and post for mutations. So you can say, we're going to have a route called query, and it's going to be called list users. And then here is actually where we define the logic. So we're going to say, we get this resolve property here. And we're just going to say, in this case, we're just going to return users. And so, like I said, I want to keep things simple. So if this was a real application, I would probably set up a Postgres database and use Prisma and all of that good stuff. But in the interest of keeping things simple, I'm just going to create an object in memory and just kind of treat that as my database and mutate that object directly. So we'll just say we're going to have, our user going to have an ID and a name. And then let's create an object called users. It's an empty array. Then we need to merge this user router with our main app router. So we just call this merge function. And then we can prepend it if we want to. We can give it like a namespace. And then we pass it in the actual user router. And then we can't, let me go ahead and type this out here. Okay, awesome. So this should work. Let's go ahead and start this, make sure it still compiles. Okay, awesome. So this is our basic tRPC backend. And now let's go ahead and scaffold out a Remix front end.
Patrick, can you explain why we have a user router as well as an app router, and then we have to merge them? Is there not the concept of a single router that does all of that?
Yes, there is a single router. The reason I do this is because I typically find myself really early on breaking my routes into separate routers. And so you could just, here, sorry, I'm really bad at multitasking. Let me just set this up really quick and then I'll answer your question. Okay, so while that's running, so we could have done this. So let me go ahead and we could just define our routes right here. So we could do something like this, and then have all of our code in here. The reason I'm doing it this way is just to kind of show you that it's possible, just so if you're going to experiment with tRPC and you're going to investigate it or use it in your next project, that you know how to merge it, how to split it up into different routers and then merge them.
Okay.
So yeah, to answer your question, yes, we can do everything in one router.
Maybe for readability, better code organization, that kind of thing.
Right, exactly. Okay, awesome. So we have our Remix app here. Well, let's go ahead and get that running. Here we go. And I'm going to add a route called users. And this is going to be the route that's going to fetch those users and kind of display them on the screen. Okay, so let's just do a ordered list, and then we'll just do something like, we'll map over these users. Okay, so what do we do now? So we have our Remix app. We have a backend running with a tRPC server. So how do we use tRPC in Remix? This is the whole point of this topic. How do we use tRPC in Remix to fetch that data? So what I'm going to do is I'm going to install. Remember I said there's multiple libraries, tRPC libraries. So we're going to install the tRPC client library in Remix. And that's what we're going to use to make requests to our backend. So we have that installed. Let's go ahead and run the dev server again. I'm going to create a new file called trpc.server.ts. And this is where we're going to instantiate our tRPC client. So let's go ahead and create our client, call it tRPC. Sorry, first we have to import the library. So we import the create tRPC client function. we invoke it, we pass it the URL. Here, I'm just going to hard code it. You would, I mean, in practice, you would load it from an environment variable. You would load this URL. But in this case, I'm just going to hard code it. And we are going to have, so our root route is just our hello world route. So we're actually going to have kind of like a path for tRPC that we're going to use for all of our tRPC routes. So that's our client, our tRPC client. And then we're not finished yet. So for this to work, we have to share the types for our tRPC API. So what we'll do is we need to import that app router type. So you can see it. We have to import the types for our routes. So that's why we exported this right here. So let's go ahead and go into our backend, tRPC, and then we pass it in here. And so it's important here to note that there's a, if you didn't already know this, you can import types directly without the type keyword, or you can add this type keyword, which is the preferred way to do it. Some linting rules will actually give you an error if you try to import it like this, because it's saying, hey, you can't import code that's outside of your application, right? And so by adding this type keyword, it knows that I'm importing these types, and that this import has no effect on the actual compiled code that's going to run in production. And so that's why it's letting me do this, because it knows it's just TypeScript. When it gets compiled to JavaScript, there will be no dependency on a file outside of the application. So just a note there. And now we go into our loader. Create a loader to load the users from our backend. And we can do something like return tRPC. This is the beauty of tRPC. So we defined a query route, and it'll auto-complete all of the available routes that we have. So we just have one. So we only have one. So let's do that. Oh, actually, sorry. Can't do just that. We need to do this. And then we need to make sure we type our loader function correctly. Okay, awesome. And so as you can see, we know the types in our front end. We have that end-to-end type safety. We know the type that our server is gonna return, which is awesome. And if I were to change this, so I go here and I say, hey, our users are gonna have emails as well. I hit save. I go over here, and now it knows that we added a new field called emails. So it's super, super slick. It's an awesome developer experience. And now we're able to use this to kind of map over and display some information. So we don't actually have users. I'm going to deal with that in a second, but I'm just going to set this up. Username, and then user email. We'll display that here. And then we'll add some dummy data here. So we'll just say, and then we'll
You don't trust us with your real email. Wow. Wow.
Okay, cool. So this is a string, should be a number. And then if we go to our users route, let me see what's going on.
Jeez.
Oh, okay. So let me see. Return users. Unexpected token and JSON position. Oh, that's interesting. I'm not sure. Huh. Let me see here. We restart the backend. So we have our users. We're returning our users when we query. Oh man, gotta love live code demos. Sorry about that. Use loader data. Yeah. Let me see. So strange. Make sure I don't have any typos anywhere. Users, querying. Okay, yep, that should work out.
On line 36, is it supposed to be user period? I just don't know enough of the syntax.
It can be whatever you want.
Okay.
So we don't actually need to namespace it. I added that so that when I'm querying it on the client,
Oh, that makes sense. I see
I
now.
can like prepend it with
Cool.
that namespace. Okay, sorry. So okay, so let me see. tRPC query. I think it might be. Maybe it's here. Oh, okay. I know what the issue is. I actually skipped a step. I apologize. So we actually, in our server code here, so to show you all what the issue is, we're sending our query to the /tRPC API endpoint, and we haven't actually implemented that in our server.
Yeah, makes sense.
We only have this get. So I apologize. So I skipped a step. Shouldn't have done that. Let's go ahead and fix that. So what we're going to do is we're actually going to use a middleware instead of defining it like this. So we'll do app.use /tRPC. And then here we're going to import our tRPC Express package. And this is going to do some magic for us. So we do tRPC Express, create Express middleware, and then we have to pass it our router from our other. So we're going to have to export the router, not just the type. So we're going to export the router. Not what we want. And then we are going to also pass it our create context function that we need to export as well. Oh, yeah. Okay, it is exported. Let me just pull that in. Okay, awesome. So let me just restart. Well, it should work. If it's using NodeMon, it should work. It should have restarted already. Okay, awesome. So yay. So it did work. Okay, cool. So let me just quickly, we added a query. Let me show you kind of how you would add a mutation as well. So we'll do this. I'm going to do this as well. Okay, and so we have our query, and then we can just kind of chain onto this. So I'm going to set a mutation, and I'm going to call this create user. And then what's awesome, so we have our resolve function, but what's awesome about tRPC is it has input validation built in with Zod. And so what we can do is if I import, just have to import Zod. We can kind of, we can validate our input. So we can say, sorry, what is this saying? Okay, so we're going to have an object. So our JSON body, when we create a user, we're going to have an object, and we know that we need ID, name, and email. The ID in a real world case would be auto-generated using some kind of UUID or ULID library. But here we're just going to make it simple, and we're just going to have a variable that we increment whenever we create a user. So what we're going to do, what we expect from the user is we're going to expect a name, which is going to be a string, and an email, which is going to be a string. And so here we get access to this input object. And this is, if we fail this validation, tRPC will automatically throw an error, and it won't even make it to our resolver function. And so if we get here, we already know with confidence that we have these attributes and that they're the correct type. So what we would do is do something like new user, we add our ID, and then we would do something like name, input.name, email, input.email. And then since we're doing kind of our kind of hacky stub database, we would just push this new user into that object. And then I'm going to return the new user. And then let's increment our ID so that it keeps going up. Okay, awesome. And then in our front end, what we would do is let's add kind of like a form. Let's add a form and a action function so we can actually create this user. So let's do name is name, and then we're going to have a email and then a submit button. Cool. Awesome. So we could add a, see, I don't know if Justin's there, but let's add Justin. So this is going to, before I get ahead of myself, this is going to go to our action function, which we need to create. And then here, what we'll do is we'll just do we'll actually we'll do this object.from entry so that we actually have an object with all of the with all of those values. And then we'll want to do something like new user. We're not using a query. We're doing a mutation. We automatically get a type error because we don't have any mutations at this path. Let's go ahead and use our autocomplete again. We have create user, but again, TypeScript's letting us know, hey, you haven't provided me with any arguments. I require a name and an email. So you can see we get that auto completion here. Form data.name, and then email will be form data.email. Awesome. So this should work. We're getting some errors here because we're not validating this form data. And so what I do in production, and what I would recommend, if you actually have a mono repo, like a true mono repo setup where you're using like turbo repo and PNPM to kind of share code and have shared packages, what I like to do, here, let me see if I can. So this and this would require kind of like it's the same type of validation, right? You need to validate you're getting a name, which is a string, and an email that's a string. So what I would do in production, I'm going to skip it here for brevity, but I would create a shared Zod schema that I would share across my tRPC server and my action function to validate those fields, both in the action and when it hits the server. So for now, I'm just going to kind of skip that. Oh, it's also complaining that they might not be of the same type, but I'm going to ignore this for now. But we could use Zod if we wanted to. We could install Zod on our client in our Remix app. And then right before we call this, we could validate form data.name and form data.email. So let's see if everything worked. Awesome. It did. So in a nutshell, that's how you can set up a tRPC backend and then use Remix as a tRPC client to consume that tRPC backend. So I'm open to questions. If we have a little bit more time, I can talk about some more advanced, some more advanced use cases. But it's really open to how many questions you have or what you all want to go into.
I have a question, and sorry if you can hear me, but with REST routes, you typically have like pretty nested routes so they can get kind of here at a certain point. But with tRPC, are they all typically going to be pretty flat, where you're just having like a list of queries and you query the endpoint with kind of the information you want to get from there, rather than like having to traverse kind of a long like REST API route?
Yes, correct. It's typically more flat, although kind of like I showed here, when you're merging routers, you can set kind of like domain, you can namespace them. So if you wanted to have, if you wanted to have kind of like to simulate a kind of nested structure, you could have, namespaces where you do, that Slack example I used where you're like removing a user from a Slack channel. You could do something like channels users and then have like a channel users router. But typically they are going to be a lot more flat than REST APIs. But if you wanted to, you can use these namespaces, like if just for your logical separation, if that helps you, you could kind of use that to split things up into their own routers, but you don't have to.
Awesome. Thanks.
Yeah, no problem. Any other questions?
What about error handling from the mutation on the server side? I see there is a resolve. Is there like a reject or an on error or something like that? Knowing there's also client validation, but is there a friendly way to pass errors back from the server?
Yeah, so there are here, so this is the tRPC website. It's just trpc.io. Like I said, I'm using version 9, version 10's coming out with it's pretty different in some ways. So just make sure you're on version 9 if you're trying to follow along. But they do have, by default, it'll automatically return a lot of errors. Like if the validation fails, it knows how to handle those errors versus if it's like a server error. And then you can kind of use this format error function. You kind of like chain it to your router. And so you can kind of like modify the way that the error is structured, or you can use like the concept of middleware also exists on the tRPC APIs. So you could use middleware to have your own error handling logic as well.
Gotcha. That makes sense. Actually, their docs look really nice.
Yeah, they have really, really great docs. I definitely recommend checking it out. And like I said earlier, they also have, if you're using React, they have a lot of adapters that make it really, really easy. Even if you're using if you can't use Remix, like let's say you're thinking of introducing tRPC at your day job, and you don't have a Remix app that you're working on, you have a Next.js app or a traditional like single page React app, bootstrapped with Create React app or something like that. They also have a lot of like good libraries and adapters for using tRPC with Next.js and just plain React apps. So it's super easy to get up and running with a lot of the common frameworks that web developers use these days. And if you're using React, to kind of go off that, they use one of the dependencies of their React adapter is React Query. And so they kind of have their own hooks which wrap around React Query that you use to call your queries and mutations. So you would use like this use query hook, and then you would if you had like a single page React application, this is kind of what you would do to query your tRPC server. Since we're using Remix and we're calling our server from our loaders and actions, which is like a Node.js environment, we just use the plain vanilla client, which is what we did. We just installed the tRPC client package and just called that directly.
It's also probably nice so you can kind of obfuscate your server's URL and address.
Yeah. Mhm.
Is the protocol, I assume being RPC, is the protocol actually binary? Is it something you could expect the network for, and you're going to see JSON, or are you going to expect it to see binary?
tRPC, I'm not too sure. I think it's JSON. I think what it does, like if you were to, here, let me see. Like for example, in this case, what tRPC does is it's going to, here, let me,
I think I'm making an assumption based on like gRPC, which is a binary protocol.
yeah,
But that may totally be a bad assumption.
Yeah, does
No.
it does it use like protocol buffers to encode the data before it gets sent?
no. So what's going to happen? So this mutation, so this call right here, if you inspect it, it's going to be a post request to here. If you look in your network tab, you're going to see this. It's going to be, and then this is going to be a JSON. This is going to be JSON, and then it's going to be, you know, whatever.
Okay, so it's still easy to debug if the network traffic, especially if you want to.
Yeah,
Okay, yeah, those protobufs they makes that kind of difficult. So okay, good to know.
hey Brooks, how am I doing on time? Do I have like 5 minutes to kind of go over something conceptually?
Yeah, for sure.
Okay, so I'm going to go over kind of like one way to, I guess, protect your tRPC server API. So normally with Remix, I think one of the most common strategies that people are using is when you log in, you create a session cookie, and then inside of your loaders, you check if the session cookie is valid. If it is, then you know the user's authenticated. If not, you kind of redirect them or throw an error. But in this case, since we have a separate backend, we could technically call, or you know, anybody could call these endpoints outside of our Remix app, right? Someone could just use Postman and they could call these routes. And so, you know, like that's when kind of like CORS comes into play and protecting your API. But one thing that I did is I wanted to use my session cookie from Remix, and use that to kind of authenticate requests on my tRPC server. And so what you can actually do is when you instantiate your tRPC server on the client side, you can pass custom headers. And so I'm not going to fully build it out, right? Because I would have to implement all the like session logic and Remix and all the session cookie logic and all that, and login form and all that. But what I would do is, I think it's, so what I would do, I'm kind of write pseudocode here, right? But what you would do essentially is, you have this header function where you can pass custom headers, and so you can pass headers a object, or you can pass it a function. And if you pass it a function, it'll invoke this function on every request. And so since we don't know if there's going to be a session cookie or not, we want to make sure that we invoke and kind of generate this headers object on every request. And so like what you would want to do is kind of in your loader, what we ended up doing on the project that I'm working on is in the loader, we would basically kind of get that session cookie, get the token from the session cookie. And then if we have one and the user is logged in, then we pass it into our headers for tRPC. So we would do something like, or actually I could just do if session token, if we have a valid Remix session token, then we would pass this custom headers object in our tRPC request. If not, we just return an empty object because we don't have any custom headers. And then what we would do on the server side is, remember this create context function? this is how tRPC recommends you do kind of like your backend validation. So what you could do is you could get like rec.headers.authorization. You could, get the token. You do something like this to get that token. And then what you would want to do is have some kind of function that validates the token. And if it's valid, or I guess you could say, so in this example, we would have a function that validates the token. So what we did is when the user signs in, we create a session object with some of the user, like the user email and the user ID. And then that token is passed to our tRPC backend. We validate the token, and then we get those user attributes, and we store them in our in our context object here. So again, if we go back, we have our session token, which we would get from like from the Remix session cookie helper functions. If we have a valid session token, we pass that token to our tRPC backend. And then in our tRPC backend, we validate that token, and then we decode it and get the payload, which we are purposely encoding some user data in that. And then we're returning an object with that data. And then in any of our tRPC queries or mutations, we can access that context. So let me just do, so this is going to throw an error because this function doesn't actually exist, but let's just say, let's just do, okay. So pretend we're validating this token, and then we're decoding it, and then we're going to include that information into our context. And then all of our queries and mutations will be able to access that context. So for example, maybe we only want this create user endpoint to be accessible by users that are authenticated. We could do something like, if context.user does not exist, throw tRPC error unauthorized, I believe, something like this. There's kind of like a helper function for creating tRPC errors. Let's see. Yeah, so we would do something like this, essentially. And I'm sorry if I did a poor job of explaining that, but you would basically kind of use this create context function to modify that shared context object to include the user information if you received a valid token from Remix. And then that's kind of how you could prevent access to this endpoint from unauthenticated users, while at the same time kind of reusing some of the authentication logic from Remix.
So that create context is called every single time you make a request.
Yes, correct. For every query and yes. So for every request, queries and mutations alike.
If you had like certain routes that are publicly accessible, but other routes that are, do need to do that validation, what's like the best way that you would architect that to split that logic up? Does that make sense?
Yeah. So you could do, you could create a middleware that kind of does this logic.
Okay.
And then, so you could create a middleware, and then here, I'm not super familiar with that, so let me go to the documentation,
Okay.
But I know you can create middlewares for like certain routes on a router.
Okay, nice.
And so you kind of do something like this. There is an example for that exact case. I think, so you would use middleware, and then, let me see here. There's kind of like this meta property. I think in the example I saw, they basically, you add a meta property. You could say like, is protected route. And then what you would do is like, you would have a middleware that says, okay, if for that route, if is protected is true, then we do our authentication check. And then if is protected is false, then we don't run that check. So you would, I guess, kind of apply middleware to the whole router, but inside that middleware, you would, check for this custom meta tag and implement the authentication logic based on that.
Okay, that makes sense.
I guess another use case for having separate routers, if you can set the metadata at the router level and maybe not at the route level.
Yeah, yes, that's a great point. I wonder if you can. But yeah, that's a great point.
Yeah, like can you add a meta to that mutation or another query or whatever? Because I can imagine wanting to, number one, maybe only people with an admin role get to create some resource, but also people just being able to query their own data. Like if you're going to go and query for your blog post, maybe you only want to be able to pull down a list of your own blog posts or edit a blog post that belongs to your user ID.
Yeah, that's a great point. So in the project that I'm working on where we're using tRPC in Remix, what we're actually doing is whenever the user signs in, we create the session cookie, and inside the session cookie, we store the role of the user. That way, when we're loading routes, we can say like, hey, this route is only accessible to users with this role. And then when we pass that session token to our tRPC server, in our case, we use a create context object. But in here, we basically validate the token and then we kind of decode the token and we have the role there. And then inside our queries and mutations, we check the user ID and the role to make sure that they have access to not only that route, but the information or the data that they're trying to query. So yeah, like you said, if they're trying to get posts, they should only be able to get posts that they wrote or maybe they can view all posts, but they can only edit posts that they specifically wrote, and that kind of thing.
I think Carlos just posted something about having sub routes or sub routers to achieve that. And in the session cookie stuff that Remix provides, are they using like Jot so that they're helping you encode that token with all the role info and that kind of thing? It's not just like plain text token that can be
right.
attacked. What all?
Yeah, I'm not exactly sure. So what I wish I could.
It's probably only a Google query away. But I've already closed the laptop, so there's no way I could possibly discover that.
It's not a fully formed JWT token, but it's like some sort of. It has a very similar syntax and a library that we actually had to use to validate the token is what Remix uses under the hood is I think there's a library called Cookie Signature, I believe. I hope I'm not getting that wrong, but I think it's like cookie-signature, and that's what Remix uses when you create the cookies with your cookie secret. That's the library that that'll validate whether or not it was signed with the right cookie secret. And so we use that library on our tRPC server to validate those session cookies from Remix.
Okay, that makes sense.
Awesome. Are there any other questions? Okay, awesome. Well, thanks for listening to my presentation.
Yeah.
So much, Patrick. That was great. More slides. Yeah, I just really want to thank Patrick again for putting that talk together, especially with starting a new job and all that jazz. So yeah, it's really cool. If you want to give a talk in the future, you can do this in a couple ways. You can just talk to me right now, or after this, don't talk to me right now, I'm presenting. Talk to me afterwards. There's a form if you'd like to just, I don't know, if that helps you think through or whatever, you can submit the Google form. You can reach out to me on Twitter. If you find my number or email somewhere, you can certainly try and use those. I'm on LinkedIn, but I don't use it very often. So that's probably maybe not the best way, but it still will work. So anyway, yeah, if you ever want to talk, lots of ideas, accessibility, internationalization, haven't seen anything on those yet. Demo cool technology like tRPC with Remix. Also lightning talks are always, if you want to get your feet wet or challenge yourself just to learn a little bit, literally just take go to remix.com or .dev or whatever it is, look at a page and say I want to do a lightning talk on this. I will never turn you down for wanting to explain the docs, because we always have people come who maybe have heard of Remix, but have never actually been into it. So it's always really nice to start with something simple or something that's a foray into it. So yeah, please reach out. And then last slide, request. So we might be building a website for this group. I say might because obviously you have to do work to build websites, but Grant has already bought a couple domains and has some ideas floating around in his head. So if you're interested in helping out in any way, please reach out. If we did this, we would very, very, very likely make it open source. So, PRs would obviously be a really good way to reach out. But if you also have ability and skill with design, that would be super helpful, because that is not something I have skill and ability with. Programming, obviously, or even just copywriting and media and thinking about marketing and all that kind of stuff. Yeah, reach out. So brainworm there. But other than that, yeah, we are done a little bit early. So feel free to hang out and keep on mingling. If you want a second dinner, I'm not going to judge you because there's plenty of food. But yeah, thank you everybody for coming out. And thank you once again, Patrick, for the great presentation on tRPC.
Yeah, very timely too, because I think I just listened to a podcast about it where they just briefly glanced over it. And that was the first time I'd heard about it. So this is the second time I've heard about it. And then now I actually learned something, because the podcast didn't give me that much.
Very cool. Thanks everyone who showed up online as well. I forgot to call you all out. Your faces are on the screen so we can see, or your names at least. Thanks everyone for coming.